Hey guys, it's Chris again, mat130. This time we're talking about complex numbers. You'll find that a lot of the rules for radicals works the same with these when you're dealing with the imaginary components. But anyways, here we go. So what we're supposed to get out of this as far as skills go, writing radicals with negative radicands, that's the term that's inside the radical, is imaginary numbers. Adding and subtracting complex numbers, multiplying complex numbers, dividing complex numbers, and raising complex numbers to powers. As far as conceptual objectives go, understand real numbers and imaginaries are subsets of complex numbers, and how to eliminate imaginary numbers in denominators. So this number I, what they do is they let the letter I stand for square root of -1, where I squared is -1. And looking at a complex number, what's a complex number? Any number of the form a plus bi, again where that I is the radical or square root of -1. A is the real component and b is the imaginary component. Basically, the complex numbers contain all the reals because of a. If b is 0, okay, there's all the reals, but it also contains the imaginaries because of the I component. So let's try simplifying the radical. This is done very, very similarly the way you normally simplify radicals. In this case, we're looking for the square root or radical -32. Well, 32 can be broken down. Whoops. Again, if you want to, go ahead and use a factor tree or something like that. But hopefully you guys would, even if you used a guess and check, 4 times 8, that would work, but the 8's going to break down again. 16 times 2 is the best one. 16 times 2 times, but we're still left with the -1 under the radical. -1. Square root of 16 is 4. Square root of -1, there's our I, and we're stuck with the 2. So standard form to write something like this with radicals would be 4i radical 2. They generally don't write the I after the radical because they're afraid that it may look like the I is underneath the radical sign. So 4i radical 2. Adding and subtracting these whoops. Adding and subtracting, basically, it's very much like what you guys do with like terms. So the real components you can add together, or combine together, the imaginary components you can combine together. So if we're going to simplify something like this, you'd add -1 plus -2 to get -3, and -3i plus, well, there's no number in front of the other I, so you think of it as a 1. So -3 plus 1 is -2. And that's a minus. Multiplying complex numbers. Well, again, it's distributive property, that sort of thing. It's very similar to what you learn in the other parts of algebra with real numbers. So I used to draw arrows. So -I times -1 would be positive I, because a minus times a minus is a plus. And then -I times 3i, well, minus times a plus is a minus. I times 3i is 3i squared. But something to keep in mind on this one is that I squared is -1. So this would be the same as I minus 3 times -1. And again, negative times a negative is a positive. So it's going to be I plus 3. Or 3 plus I if you prefer. Then they talk about these things called conjugates. Okay, well, basically, complex conjugates work the same as the conjugates we were doing before with just regular radicals. The conjugate of a plus bi, keeping in mind that I is square root of -1, is a minus bi. And that's basically all this thing's saying. How they use this is very similar to when we were dividing with, when we were dividing with radicals in the denominator, and we would do a conjugate of something, something plus radical something or something minus radical something, and just switch the operation. Because when you go through and you FOIL it, you'll see that the outer and the inner terms cancel. So it's very similar with this. Okay. So again, say we want to, this is considered bad form to have a radical in the denominator, because that's what that I is, the 1 minus 5i in the denominator. That I is the square root of -1. So we're going to use this idea of a conjugate to get rid of this. The complex conjugate of 1 minus 5i would be 1 plus 5i. So multiply by 1 plus 5i. But you can't multiply by 1 plus 5i because you feel like it, unless you do the same thing at the top. And then just go through and use your FOIL on the bottom, or your double distribution, or how you want to say that, and distributive property on the top. So doing the numerator, negative I times 1 is still negative I. Negative I times 5i, it's going to be a minus 5i squared. Because I times I is I squared. On the bottom, we're going to FOIL that thing. So 1 times 1 is 1. You got a plus 5i. You got a minus 5i. And you got minus 5i times plus 5i is minus 25i squared. So again, keep in mind I squared is -1. Something to keep in mind, maybe off on the side. I squared equals -1. So for the numerator, you'd have negative I minus 5 times -1, because that's what I squared is, over, well, 1, the 5i minus the 5i cancel, minus 25, and then I squared is -1. So you'd have negative I plus 5 over, well, minus times a minus is a plus, so it'd be 1 plus 25. So negative I plus 5 over 26. Or if you're like me, you don't really like reading it as negative I plus 5. I'd rather see that as 5 minus I over 26. Plus, that's more in the form that they like. Or you can even split that up to 5 over 26 minus 1 over 26i. But anyways. The last thing we're going to talk about is raising complex numbers to integer powers. Something like simplifying I to the 35th power. Well, here's something to keep in mind. If you have I by itself, I to the first is just I. If you have I to the second, that's -1. If you have I to the third, well, that's I to the second times I to the first. But I to the second is -1, so this is going to be negative I. It's negative I. I'm sorry. Just goofed that, I think. Let me erase this. So negative I. Then if you have I to the fourth, well, that's I squared times I squared. So that's going to be -1 times -1, which equals 1. And then I to the fifth is going to be I to the fourth times I to the first. But I to the fourth was 1, so it's 1 times I, which is I. I to the sixth is going to be I to the fourth times I squared, which is 1 times I squared, which is -1, which is -1. And if you keep going, hopefully you'll see the pattern is it's going to start cycling over and over again. It's just going to repeat itself. It goes I, -1, negative I, 1. Then it goes back to I, -1. It's going to keep going, negative I, 1. So the trick here, since it cycles every 4, So the trick here, since it cycles every 4, just take whatever the power is that you're raising I to and divide it by 4 and see what the remainder is. So let's do this. So if you take 35 and divide it by 4, 8 times 4 is 32. 35 minus 32 is 3. So that's the remainder is 3. So I to the 35th is going to be the same as I to the 3rd, which was negative I. Right in standard form, the last one, 2 plus 3i to the 3rd. Okay, well if you expand this through binomial expansion, 2 plus 3i times 2 plus 3i times 2 plus 3i, 2 plus 3i, 2 plus 3i, 2 plus 3i. Or you can just going brute force method, foiling it and then again. You have 2 times 2 is 4. You got 3i times 2, which is 6i. And another 3i times 2, which is 6i. Well, 6 and 6 is 12. And 3i times 3i, which is 9i squared. But I squared is negative 1, so it's actually minus 9. So this thing would be negative 5 plus 12i times our 2 plus 3i. So if we do this, you'd have negative 5 times 2 is negative 10. You'd have minus 15i plus 24i plus 36i squared, which would be negative 10. Let's see, 24 minus 15 is 9, so plus 9i. And then 36i squared would be 36 times negative 1. So let's see, negative 10 minus 36 is negative 46 plus the 9i. And that would be the standard form for this thing. Anyways, that's all she wrote. Again, if you have any questions, feel free to contact me. Out.